a lot of people find vectors more difficult than calculus. So this lecture is going to sound like, oh, vectors not bad, piece of cake. Honestly, because we're just going to talk about the definition of vectors, what they are, but then their applications and what kind of problems they can solve it's very, very visual mathematics, right? So these basics are actually all we need to solve the difficult problems. Extremely important, but it's going to sound extremely simple today. Okay, so let's start with what the definition of vector is. Definition of vector. First of all, let me define the word magnitude. Before I actually define this, magnitude. Magnitude. Okay, so magnitude is referring to the size. Okay, size of a number. Okay. So the function that we use to describe the size of a number is absolute values. Remember this? What does that give you? Absolute value of -3. It gives you 3. This gives you 5. What the absolute value does is that it doesn't care about the sign of the number, it just cares about the size. Right? So that's what we mean by magnitude. Okay. Now on a number line, like 3 and -3, they sort of have direction, right? On a number line, 3 means, let's say, like 1, 2, 3, to the right, a direction to the right. -3 means -1, 2, 3, -3, this way, right? Okay. Except, so this integers have 2 directions, positive direction, negative direction. A vector is something with a magnitude, defined by a magnitude, just how long it is, or how big it is, and direction. Okay, and this direction does not mean just positive or negative. It can be like rotated by 30 degrees or whatever. Okay. Right. So this is the definition. Now it has to have these 2 things. You can't just have one. Then it's not a vector. It must contain both of them. Okay. So if you take in physics, there's a lot of reference to physics in this course. Okay. In fact, our application section is going to be all physics. Okay. So it'll help you if you've done physics, grade 11 physics. This course, that part of the course is going to sound easier. Okay. If you haven't done it, we have to go through a little bit slower. Make sure you know all the terminology. Okay. So, who here have taken physics?
I didn't take science at all.
You take any science? Have you taken any physics? Okay. Well, Daisy sort of, because Daisy did a little preview of this course in the summer. So, what's an example of a vector in physics? Brian.
Like velocity.
Right. Okay. So, why is velocity? What is actually the magnitude version of velocity? So velocity, you're saying it's a vector quantity.
Yeah.
Okay. That means it's got a size and it's got a direction, right? So what's just the size called?
You mean like the scalar?
Yeah, the scalar of velocity. What is
Speed.
it? That's right, speed. Speed. The word speed. So if you use the word speed, usually you say speed is 60 kilometers per hour, right? You know how fast it's going, but do you know which direction you're going? Right. This is, we call it scalar quantity. Scalar, the word scalar is very similar, almost equal to magnitude. Okay. Velocity, if you want to describe velocity, you have to do it in the following way. Let's say you say like 40 kilometers per hour, but you're going like east 20 degrees north. You have to give it direction like this. Otherwise, it wouldn't be a velocity. Okay, so this notation here is very popular in physics. It means the following: east 20 degrees north. It's like this. So we're going east, but we're rotating towards north. 20 degrees only. Okay, and if you can actually get the length of this line will be 40 kilometers. Okay, 40 kilometers. 40 kilometers per hour. Okay, so so I said this is 40. So what would a 10 look like?
Quarter of that.
Only a quarter of that, exactly. Very, very common sense, right? So if I said like this is 20 degrees, and I said this is 40 kilometers per hour, I must mean only a quarter of that. So if I draw a length only a quarter of that, it has to be completely parallel. I'm going to just draw a little bit on top. That will be 10 kilometers per hour. Okay, what if I wanted a velocity of minus 20 kilometers per hour, and it's at still same direction, east 20 degrees north? What would that look like? Okay, so we'll go that way. This full length from the beginning to end, this will be exactly this vector here, 20 kilometers per hour, minus 20 kilometers per hour, and east 20 degrees north. Okay. All right.